Alright, geometry. So, what we're going to be working on today is 2.8 proving angle relationships. I do have some good news about proofs. I'll tell you near the end of the lesson, okay? So, your homework is page 156 and 157, 1 through 13 all. Alright, here we go. So, right here, 2.8 proving angle relationships. What we did in the past is we identified and used special pairs of angles. We have done that, right? Special pairs of angles. Remember the special ones? The linear pair, vertical angles, right? We talked about all those relationships, adjacent angles, supplementary, complementary, right? The now, though, is write proofs involving supplementary and complementary angles. Proofs. And write proofs involving congruent and right angles. Now, there's something special about proofs, and I'm going to tell you about that later. Now, supplementary and complementary angles. Now, remember, supplementary equals 180. Complementary are two angles that add up to give me 90. Okay? So just remember that. Don't forget that meaning. If you're not sure, remember, check that vocab. Alright? Now, first postulate. The protractor postulate is very similar to the last section of the ruler one. What they're saying is given any angle, the measure can be put into one-to-one correspondence with row numbers between 0 and 180. What they're trying to say is that if I have a spot and I'm using a protractor, my angle, no matter how I measure it for this 180 part, is always going to be either what? Positive 1 to 180 degrees. Alright, I'm always going to get that. Alright, so that's what that protractor postulate is saying. It's saying no matter what, if I measure an angle using a protractor, I'm going to have a positive degree. I'm going to have either 1 to 180. Now, in lesson 2-7, we learned about the segment addition postulate, right? It's saying that if I have one piece plus another piece together, I get a whole piece. Well, the same thing works also for an angle. An angle does the same thing. An angle, they're saying if I have one small angle, see, if I have one angle here plus another little angle, I get one big angle. So right there, if I say angle ABD plus angle DBC, well, I end up getting angle ABC, which is what they're telling us right here. They're saying that if I add the two angles together, I get one big angle. Now remember, ABD with CBD, those are also adjacent angles. Why? They're two angles that are right next to each other. Alright? That's what the angle addition postulate is telling us. The angle addition postulate is letting us know, hey, those two angles, if we add two angles together, we end up with one big angle. One angle plus another little angle, put them together with one big angle. Just like the segment addition postulate. So example 1 is saying, how do we use that? How can we use that in math? How do we use it to solve? So here's what happens. Let's read carefully. It says, find the measure of angle 1 if the measure of angle 2 equals 56. Okay, I'm going to mark that. Measure of angle 2 is 56. Okay? And measure of angle JKL is 145. JKL, ooh, that's the whole thing, is 145. Okay. So, what ends up happening here is, do we have anything? Well, I could find the measure of angle 1. How? A little bit different. See, they're letting us know that the measure of angle 1, this angle plus angle 2, 1 plus 2 is going to give me the whole thing. So, if I do that, I get measure of angle 1 plus measure of angle 2. Where did they get that? All they did was substitute. Right? Now, in order to get measure of angle 1, it's just like solving for a variable. I'm going to subtract 56 from both sides, and I end up measure of angle 1 equals 89. And I'm done. That's it. You can go the other way around. It just depends on the problem. Let's look at the guided practice. It says if measure of angle 1 equals 23. Okay, mark that, 23. Let me erase this, get a little more clear. Okay, mark that, this is 23. Alright, measure of angle ABC is 131. Ooh, ABC, the whole thing is 131. Alright, find the measure of angle 3, justify each step. Well, there's something special about this one. What is angle 2? Angle 2 has that little square. Remember, the little square means that that angle is 90 degrees. We know that a right angle is 90 degrees. So, if 90, so measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals, what is it? 131. Alright? Measure of angle 1 is 23 plus measure of angle 2 we said is 90 because it's a right angle plus measure of angle 3 equals 131. Well, I'm going to combine these two. 90 plus 23 is 113 plus measure of angle 3 equals 131. Subtract 113. And I end up with measure of angle 3 equals, let's see, 7 is 120, so 17, 18 degrees. And look, that looks about right, 18 degrees. And that's it, and I'm done. That's all you're going to be doing for your homework. Now let's go on to the next page. The next page is the angle addition postulate can be used with other angle relationships to provide additional theorems relating to angles. Well, the supplement theorem. We already know this one, right? But now it's a theorem. I kind of told you this last time. Supplement theorem says if two angles form a linear pair, then they are supplementary angles, saying that if two angles add up to 180, then they are supplementary. The complement theorem, which you should write down and use as an example, is saying if two angles add up to 90 degrees, then they're complementary, or complements. Alright? Let's look at a real-world example. Real-world example 2 is saying use supplement or complement to solve this. Alright? So, how am I going to do that? Well, what ends up happening here is it says using a transit, surveyor lights the surveyor sights the top of a hill and records an angle measure of about 73 degrees. What is the measure of the angle the top of the hill makes with the horizon? Justify each step. So what they want to know is what is angle 2 with the horizon, right? The flat one. Well, we know from here, angle 1 to the top of the hill, they said was 73 degrees. It says that right there. Now, notice that, let me erase, there's a square. That means this makes a right angle. So that means measure of angle 1 plus measure of angle 2 has to equal 90 degrees. And we know, look at, they're already setting it up. We know that this measure of 1 is 73. So measure of 2, to solve it, I'm going to subtract 73. I get what? 17 degrees. Very easy, guys. Again, the picture helps a lot. But let's go to guided practice. It says angle 6 and angle 7 form a linear pair. Linear pair, what's that? Remember, linear pair is 180 degrees. Two angles that equal 180 degrees. So, here's what happens. They say the measure of angle 6 is 3x plus 2. And they said the measure of angle 7 is 5x plus 12. Alright. Now remember, these two together equal what? 180 degrees. How do I know that? Because it says that they form a linear pair. So I'm going to put 3x plus 2 plus 5x plus 12 has to equal what? 180. This angle plus this angle equals linear pair, which equals 180. So now I'm going to solve. I'm going to combine like terms. 8x. 2 plus 12 is 14 equals 180. I'm going to subtract 14. And if 8x equals 166 divided by 8, I get 2. So I get x equals 166 over 8, or x equals well, how much does it go? 166.8 to 16.060. Okay, 0.0. That's 20.75. If you want to leave it as a fraction, that is okay too. I don't have a problem with that. Alright? Very straightforward, guys. Very straightforward. Now, here's where it gets exciting. Or not yet. Almost. We're almost there. Alright? Where you guys are going to get super stoked. Actually, like, ridiculously stoked, probably. So, here's what happens. Now we're talking about properties of congruent angles. Well, remember, like in segments, same thing. Reflexive property of congruence is saying what? It's saying that the angle has to be congruent to itself. Symmetric property is, if angle 1 is congruent to angle 2, I can also say that angle 2 is congruent to angle 1. I can flip it. And transitive property is, again, cutting out the middle. If angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then I can cut out the middleman. Oops. I can cut out the middleman, the 2, and I could say angle 1 is congruent to angle 3. Symmetric property of congruence, they're just proving to you how that works. Alright? This is not anything that you really need to copy. They're just showing you, like, how did the math people of the world figure this out, that it always works. So don't worry about that too much. But if you want to read it, go ahead. Congruent. Now some more theorems. Make sure you add all of these to your vocab list. Congruent supplements theorem, saying angles supplementary to the same angle or to congruent angles are congruent. This one's a little trickier. It's saying, for example, I like their example. It says if measure of angle 1 plus measure of angle 2 is 180, and measure of angle 2 plus measure of angle 3 is 180, then what? It's kind of like transitive. Look at, if I cut off the middleman, they're saying then measure of angle 1 plus measure of angle 3 has to equal 180. So those two have to be congruent. For example, they're saying, see, let's say this were 50 degrees, this were 130 degrees, and if these two add up to 180, right, and angle 2 and angle 3 add up to 180, well, the only thing angle 3 can be is also 50 degrees, which means angle 1 is congruent to angle 3. Alright? Kind of common sense, but it always works. That's why it's a theorem. Theorems are kind of like postulates. They're fact. Alright? Congruent complements theorem is somewhat interesting as well. Same thing as supplement, except for 90 degrees. They're saying, let's say angle 4 is 30, angle 5 is 60, they add up to be 90, and they also say that angle 5 and angle 6 add up to be 90. Well, that means angle 6 has to be 30 degrees as well, meaning that angle 4 is congruent to angle 6. Alright? Cutting out that middleman. That's what those theorems are saying. Okay? Now 154, we have a proof. Oh no. Here's what's cool. Double check the curriculum. I was showing period 5 this yesterday actually. And I found out, remember I was saying that proofs are going extinct? Well, in Southwest curriculum, they actually want us to teach this, but minus the proofs. So you guys don't have to worry about proofs, or at least not yet, not for these. So proofs don't exist, so don't worry about proofs. So we don't have to do example 3. But what we do need to look at is vertical angles. And we've talked about this already. Vertical angles, right, are two angles that are above each other, right, from two straight lines. You get vertical angles from two straight lines. You see how these two straight lines cross right here? So I end up getting 2 is vertical to 4, and 1 is vertical to 3. Now what is special about that? Well, what's special is that vertical angles are always congruent. Vertical angles are congruent. That is a theorem. That is a fact. Okay? So example 4, the proof. Don't have to worry about proof. So we're fine. We do have more theorems though. Look how many theorems we have. That's what I'm saying. Make sure you write them all. This says perpendicular lines. So one of them saying perpendicular lines intersect to form 4 right angles. So what they're saying is two lines that are perpendicular always make what? 4 right angles. 90, 90, 90, 90. And we saw this in Southwest, right? Anything that's perpendicular always makes 4 right angles if they cross each other. This one, straight up true. 2 is all right angles are what? Well, they're congruent. If right angles are 90 degrees, that means all right angles are 90 degrees, meaning they're all the same. That's common sense. You might not want to write that one, but just to be safe. It says perpendicular lines form congruent adjacent angles. So that's interesting. They're saying perpendicular lines. So let's take a look at this one. If these lines are perpendicular, all 4 are congruent, but also all 4 of them are also what? Congruent adjacent angles. Adjacent, 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 adjacent. They're all adjacent, technically. One's adjacent to each other, so they're all congruent. That one's kind of a weird one, but not too bad. It's just saying that if they're perpendicular, that means they're all 90. That means even though they're adjacent, this one's next to this one's next to that one's next to that one, they're all congruent, right? 2.12 says, if two angles are congruent and supplementary, then each angle is a right angle. So they're saying if angle 5 is congruent to angle 6, and angle 5 and angle 6 are supplementary, well then the only way that could happen is 90 plus 90, right? I can't say one's 89, then the other has to be 91. They're not congruent. 88, the other's 92. That's not congruent. So if two angles are congruent, if they're the same and they're supplementary, they are all okay. So 2.12 is saying that can't draw. Where I left off was that two angles that are congruent and supplementary have to both equal 90 degrees. They have to both be right angles. 2.12 and 2.13 kind of are the same thing. They're saying, well, if two congruent angles form a linear pair, which is what? Linear pair is 180 degrees, which is what? Supplementary, right? So if two congruent angles form a linear pair, then those two angles have to be also right angles. These all kind of go hand in hand, but I would copy these just to be safe. Now, the next thing is your homework. Notice I put an X right now on the proof. Why? I have it that you should do it 1 through 13 all. You don't have to do number 6 though, because again, Southwest, our curriculum shows that we don't have to do proofs. Alright, proofs, at least not yet, for these chapters. That's what we decided on. So, make sure you try the other ones, but you don't have to do 6. I would like you to try 6 if you want to. Okay? Alright, if you have questions, make sure you ask me. I'll be there after school. Tomorrow we'll go over some of these problems and see if we move forward.